Hello everyone, my name is John. Today I'm gonna show you how to rebuild a system that I have already built, which is called the breathalyzer smart key. To begin with, I will talk a little bit about the problem why I built this system. So ever since the rate of accident fatality in my country is quite high due to the lack of self-awareness of our people, so they kept driving while getting drunk. So to prevent that, I have built this system so as long as the BAC level of the driver within the limit, the door is open, otherwise it's kept closing. So my system contains 3 organs. The first organ I name it a key, the second is the alcohol detection, the third one is the buzzer, and the fourth one is a Raspberry Pi. So firstly, I'm gonna demonstrate a little bit about the first organ, which is named key. So for this key, I have a button for emergency situation and the LED as the indication of when the door is open. So as you can see here, that's how I'm wiring the system. So I have a 3v3 volt connect, the GND connect, the button connect to the pin number D4, the LED connect to the pin number D6. So this key will at first will subscribe to the organ here that have a alcohol detection just right here. So as long as the BAC within the limit, this LED will turn on. Otherwise, if the driver is not blowing into it or getting drunk, the LED will keep shutting. And the second subscribe is to this Raspberry Pi, which has one button just right here. And whenever the emergency button here is pressed, the buzzer just right here will be rang, alert the people nearby, and then that people or person can open the door remotely by just pressing this button. And as well, the IFTT will be sent into their phone. So I will show you the code and how I'm built it. So firstly, I'm using the MQTT protocols, so I have to include the library of it. And here I have put the LED pin, the ER button to each pin. In this situation, the LED will be D6, the ER button will be D3, and the boolean pressed, when it pressed, will be false. And here is the IP of the Raspberry Pi. So whenever the Raspberry Pi publish number 1, which is the button was pressed, the LED will turn high, and when it's not pressed, the LED will turn low. And here's the alcohol react, so it's subscribed to the alcohol detection, and it has 3 states. One is drunk, the LED is low and delay for 1 second. And if it's normal, the LED will turn on. And if nobody blow into it, to the alcohol, it will turn low. And here is the way I have built the HTML. So I have a LED toggle. I'm using the particle function for it. So when the command is on, the LED will turn on for 1 second, and when nothing happen or when I press off, it will be off. Here's the how I'm set up. So it's first subscribed to the alcohol detection and have a function to turn on the LED by the HTML, and this is the client connect to the server, to the Raspberry Pi, which is named testing. And here to the void loop, I have to check the button when it's pressed or not. The flags that I'm using is a boolean pressed, ensure that only singular event is called for each state, and when it pressed, the boolean will be true, and then it publish the buzzer to the buzzer state that is on, and publish to the IFTT and delay for 30 seconds. Move on to the alcohol sensors. This is how I'm wiring it. Pretty easy. So this one, so whenever you want to, detect the alcohol sensor, you have to blow into this thing, the white things over here. So here I'm showing you how the code look like, the alcohol sensors. So for this code, I have to put the alcohol pin at the output, and first I'm going to let the alcohol pin as low. To the loop, I have a sensor volt, the RS gas, the ratio. So I will use the RS gas as the BAC level. So as I observe, when the RS gas is under 0.09, it state that nobody is blowing. So I will publish the alcohol state at blowing needed and delay for 5 seconds. And when the normal state will be in between of 0.1 sorry, and below 1. When it's normal, it will publish the state as normal and delay for 5 seconds. So in here, since the alcohol sensors detect constantly the value, the BAC level, so if the delay in the drunk state is just 5 seconds, and then after 5 seconds it will reduce into normal state and to the blowing needed state. So it will turn on the LED and the system will be fault. So in here I have delay as a period of 12 hours. So after 12 hours, the system will detect it again, and if in that state the driver is not drunk, the LED will turn on, otherwise it will go into drunk again and wait for another 12 hours. And move on to the buzzer. So as you can see here, the buzzer is just the system that alerts the people nearby when the situation happens. So in here I'll show you how the code look like. So in here I'm using it as a Mario song. So whenever it detects the event that published by the key, it would turn on the Mario song. So I have a buzzer pin right here to the D5 pin in the organ, in the melody. So whenever the data that been published by the key, the first icon, is off, nothing happened, it will return. And when it published the on, the button, the emergency button is pressed, the buzzer will turn on like this, have a in this note, something like that, divider, and the turn buzzer will ring. Yeah. So that ons for the buzzer. And for the Raspberry Pi, this is using the MQTT protocols. So it has the button right here. So it will send every minute. It will send the value every minute. So when you press it, the value will be 1, and when it detects when this Argon detect 1, the LED will turn on, indicated the door is open. So whenever the situation happen, you press this, the LED will be turned on, and nothing. If nothing happened, you didn't press it, it will turn off. So here I'm showing you how the code look like. So I wired it, so I have you to the GitHub. So first I will import it to the MQTT. I'm using the library of PyHole MQTT as published. Of course, I have a GPIO pin and time. So I indicate the pin of the button is 4 on the Raspberry Pi. I set warning at false. The board is BCM and set up it. So while it's true, if the GPIO input of the button is high, when you press it, it will send in 1. And published single testing 1, the data is 1, but the host name is the IP address, and time slip 2. So whenever the button is pressed, it will sending value. It's sending a string is 1, and whenever it's not pressing, it will keep looping, sending 0 with the IP address, and time slip is 2. So that's all how you rebuild the system, and thank you for listening.